4.2, we're going to learn about congruent triangles. So two geometric figures are congruent if they have exactly the same shape and the same size. So you can see in the picture here, these are congruent polygons. Remember, a polygon is a multi-sided figure that's closed. So these are congruent. They're the same shape, the same size. These are not congruent because they're different sizes, different shapes. So in two congruent polygons, all the parts of one figure are congruent to the corresponding parts of the other figure. So let's read that again. So in congruent polygons, all of the parts of one figure are congruent to the corresponding parts of the other figure. So there's that word corresponding again. So it's going to mean relatively the same thing. Corresponding is going to mean it's the angle or the side that's in the same place or the same position from one triangle to the other. In congruent polygons, this means that the corresponding sides and the corresponding angles are congruent. So we're going to have one angle from one triangle is going to be congruent to the other, and a side is going to be congruent to another side. All right, congruency statements. A congruency statement is simply where you are stating with symbols and letters, like triangle, RVS is congruent to triangle ABF. So that's the congruency statement. It's just where you're using the symbols and the letters and the congruent sign and stating that two triangles are congruent to one another. When you write a congruency statement for two polygons, always list the corresponding vertices in the same order. So it's going to be very, very important the order that you write congruency statements, because one letter out of place and the whole thing can be wrong. So you really, really, really have to pay attention to order. Now, you can write congruency statements in many ways, more than one way. So you can write congruency statements in more than one way. I mean, it's even, you can write it in many different ways. So let's look at the triangles here on the right, and we have triangle ABC and triangle FED. So we're going to write some of the possible congruency statements based off of these triangles. Now remember, to write a congruency statement, you have to match up corresponding vertices. If I start here with A, you'll notice A has the one arc. That means that this angle over on the other triangle that has the one arc is going to be its corresponding angle. So if we start with A, and let's just start writing one, and we go, okay, triangle ABC. This is where you really have to pay attention to the order, because you started at A, and then you went around this way to C. Well, if you're going to say what triangle is congruent to that one, you have to say things in the same order. So since A has the one mark, we're going to start at F. Then we have to go around in the same direction, so this statement must match as triangle FED. So that's what it means by making sure all of the corresponding pieces are lined up. And you know pieces correspond based on these congruency marks that they've put for us. The A has 1, B and E have 2, and C and D have 3 in the angles. And the same thing with the sides. 1 mark and 1 mark means those correspond. Now, you don't have to start down here in this corner with A. You can also start up here in this corner with B. So if we wrote, you can write a different congruency statement. And let's just say we're going to start at B, and it doesn't matter which direction you go around in. You can go from BCA or you can say BAC. So the first statement that you start off with in your one congruency statement, it doesn't matter the direction you go. So we'll go, let's say this time we're going to go BAC. So triangle BAC. Now, the second triangle in the statement must match the order of the first one. So we have to start here with E, and we have to go around in the same exact direction. So the one that has to match is EFD. So you can see here how you can have many different congruency statements. So the main thing that I check for as a teacher is saying, okay, let's look here. A and F are both in the first position. Are A and F also in the same position in this one? Yes, A is the center letter and F is the center letter. B corresponds with E, so they're both in the middle. B and E, both up front, so they both have to be in the same position. All right, we can write a different one. Let's say we wanted to start at, and again, it doesn't matter what triangle either really you start with. So if we start with C, and let's go around, we're going to go CAB. So CAB. Then we have to make sure we match the order of the other triangle. So we're going to have to start at D and go DFE. And again, you can check yourself, because in this first one you said that A corresponds with F, because that's what your picture told you, that A corresponds with F. Make sure in each one that they're both in the same position. All right, so now we can list our corresponding angles and sides. So all the corresponding angles, so A is going to correspond to F. Then we will have angle B is going to correspond to angle E. And we have angle C is going to correspond to angle D. So those are all the corresponding angles. Now we can also list corresponding sides. And again, that's still marked. See how this has one tick mark and this side has one tick mark? So we can say that side AB is going to correspond to FE. All right, we have side BC is going to correspond to ED, and those are sides, so those are segments, so they need to make sure they have the little segment bar on top. And the last one, CA, is going to correspond to DF. There you go. Now, I would like you to try to write a congruency statement for the two triangles right here. So you're going to write a congruency statement, and you're going to list all the corresponding angles and the corresponding sides. It doesn't matter what order you do those things in, if you prefer to do the angles over the sides. This is little visual reasoning to help you, because what you notice here is that the triangles are not facing the same direction as they were in our first example. So sometimes it helps if you redraw things facing in the same direction so that it's easier to identify which pieces correspond. So you pause it, try that on your own, and then come back and check. So first what I'm going to do is list the corresponding angles. And again, it doesn't matter which one you start with. I'm just going to go ahead and start with the one that has one tick mark. So I'm going to say, all right, angle K is going to correspond to angle S. And L has two tick marks, so L is going to correspond to R. So you can see here, L corresponds to R, so this triangle is kind of turned around. And the last one, angle J, it has three circles there, or arcs, so it's going to correspond to angle T. So those are corresponding angles. Now we can do the sides. And again, it doesn't matter which one you start with. I'm just going to start with the one with one mark. So JK is going to correspond to the same one that has one tick mark, ST. Then let's go. KL is going to correspond to, it has two tick marks, so it's going to correspond to SR. And last but not least, we have JL is going to correspond to RT. So those are all the corresponding angles and corresponding sides. Now let's write the congruency statement. And again, it doesn't matter. We're going to say, okay, congruency statements, we use symbols and letters. So triangle. It doesn't matter which one of these you start out with, and it doesn't matter which order you do the first one in. All right, I'm just going to start down here, and typically I like to go in alphabetical order, but again, it doesn't matter. So I'm going to start down here where they're facing the same direction so you can see that better. JKL. So I'm going to say, all right, triangle JKL is going to be congruent to triangle. Now the second part here is what matters. So since I went from J and I went around to KL, I've got to match or mimic the same exact order. So I'm going to have to start at T, and I'm going to have to go TSR. So that's what matches, TSR. And again, you can check yourself, because what this statement is saying is that J corresponds to T. Well, is that what you said down here in your angles? Yes, it is. J corresponds to T. See, that's why I like to do these first, so then I can make sure and double check that this is right. So K corresponds to S. Yes, that's what we said there. L corresponds to R. That's what we said right there. Good job. All right, this last one is kind of a review from the 4.1 where we classified triangles by its sides and we can classify by its angles. So to classify triangles by its sides, right here, basically we need to know the length, or remember that's AKA also known as the distance of all the sides. So let's deal with this first. So we have to know the length or the distance of all the sides. So remember, you can do the distance formula 3 times here, or what I prefer to do is Pythagorean theorem. So remember, you're going to use the graph and create a right triangle. I like to redraw my right triangles. And you're going to find the length of each side based off of the grid. So this side is 2 units, and this side is 3 units. The side that you're actually trying to find the length of is always the hypotenuse. That's always going to be your x. So now what you're going to do is Pythagorean theorem. And remember, that is a squared plus b squared equals c squared. Then you're going to plug in the information. So 2 squared plus 3 squared is going to equal x squared. So remember, these sides, this is A and B. A and B, it doesn't matter which one's A and which one's B. C must always be the hypotenuse and opposite from the 90-degree angle. So now you're just going to go through and solve this for x. 2 squared is 4, 3 squared is 9, equals x squared. So 13 is x squared. You have to take the square root of each side, and then you can get your answer is 3.6. So this side of the triangle there is 3.6. So now you're just going to continue to build your triangles. So now let's continue to find the length of the other side. We'll rebuild this triangle. Again, we're going to get the lengths from the graph. So this is 1, 2, 3, 4, 5, 6 units. And then this is 1, 2, 3, 4 units. And then we're just going to do Pythagorean theorem again. So a squared plus b squared is going to give you c squared. Remember again, the hypotenuse is always the length that you're actually looking for on the triangle. 4 squared is 16. 16 squared is 36. So 16 plus 36 is 52. Take the square root of each side. And we have the square root of 52 is 7.2. Okay, so this one is 7.2. Now we have to find the length of one more side of the triangle. And it's kind of a little skinny triangle. This side of it is 1, and the other side is 1, 2, 3, 4, 5, 6, 7, 8. So Pythagorean theorem again. So 1 squared is 1. This is 64. So you have 65 is x squared. Take the square root of each side. So the square root of 65 is 8.06. Okay, so now you can see that none of the sides are the same length. The word we use to describe no sides as the same is scalene. Now, the next part of the question is asking, all right, determine if it is a right triangle. Well, if it's a right triangle, then the legs, all right, will be perpendicular. So we have to figure out, are they perpendicular? So remember what we know about perpendicular lines. If this is a right angle right here, this side, RT, will be perpendicular to TS. We only know these sides are perpendicular if indeed we know the slope. So we're going to count the slope of these sides. So the slope of, we'll say the slope of TS, and I'm just going to count rise over run. So from T to S, I'm going to go up 1, 2, 3. So I rose 3, and I went over 2. Up 1, 2, 3 over 2. Now we need the slope of RT. So again, I'm just going to count rise over run. So here, up 1, 2, 3, 4. So I went up 4. And then I went 1, 2, 3, 4, 5, back 6. So backward 6. This reduces to a negative 2/3. Now you compare your slopes. You have 3/2, negative 2/3. And what you're asking yourself is, are they opposite reciprocals? Yes. So yes, they're opposite reciprocals, therefore they're perpendicular. Therefore, yes, it is a right triangle. So you have a right scaling triangle.